We have looked at it how to use DesignBuilder's parametric analysis tool. Now, if we want a little more power, for example, to have more than 2 parameters, and to process and plot data our own way, we can use the EnergyPlus model directly. DesignBuilder uses EnergyPlus as the simulation engine, which means whatever model you have created in DesignBuilder, it will have to convert it into the input file for EnergyPlus, and then call EnergyPlus to run the simulation. The EnergyPlus input file is called the IDF model, which is a text file containing certain contents in a certain format. Since it is a text file, it is quite easy to manipulate if you know if you have some basic knowledge of the IDF format, of course. So let's have a look at what IDF model is and how to use EnergyPlus to run simulations. To get the EnergyPlus input file, we'll use File and Export EnergyPlus input file and Simulation option. But before that, let's add some shading to our window. Let's go to Opening and External Window, and you will see a field called Shading. Click on that. There are 2 options. Let's add some local shading. And if you click on that, it's called an overhang. And if you open this, you can actually see what they are. So there are 3 types. You can have a louvers, you can have an overhang, which is a surface above the window, or you can have set fins. So you make those choices in here, and there are different fields to set. We will keep it simple, so we just use a simple overhang. So I'll actually cancel it and use the template for that. So now the overhang has been added. If you go back to layout, you'll see a little piece appearing above the window. So when we export model, it should contain a overhang above that window. So now let's go to File, Export EnergyPlus input file, and Simulation. This should bring up a dialog similar to that when you run simulation, and there you can choose the output and the simulation options. We actually need to change that to 6 because that's the minimum recommended time step. 2 will cause too much error. The other things, you should know what they are and check if that fits your purpose or not. They are actually quite important fields to check. We're not going to touch it today, but when you're doing your studies, you need to know what they are. For output, I think what I've been chosen is okay. And we want summary report. I think what's been selected is alright. Okay, I'll click on OK. So DesignBuilder will compile the model and prepare the contents for the export. Just that, and click on OK. Now I'll put my input file. My EnergyPlus input file is I'll call it a shoebox base, and save. Okay. Now if you go to the folder, you will see our IDF file is here. So what's in this file? We know it is a text file, so let's open it in the text editor. There we go. You see the syntax of this file is fairly straightforward. The exclamation mark marks a command line, like in this one and that, and also here. If all the comments are removed from this file, it won't affect the model. the contents are organized in blocks, and they are separated by semicolons, like here and there. This is the first block, or we call it a object. The first field is the type of this object, followed by other fields, and these fields are separated by commas, like in here and there. The first object, as we can see here, is called a version, and it has only one field, which is the version number. And the next one is slightly more complex. It's called a run period, which defines how long the simulation should be run. So it says start from 1st of January to the 31st of December. So how many objects are there in this file? If you scroll down to the bottom, and we can see quite a lot. Mind you that this is probably the simplest model you can normally get. If you have a building with say 200 zones, thousands of surfaces, and a full HVAC system, well, the file can be very long indeed. What are the objects in this file? It won't be easy to figure out by just going through the text file. It's just too long. The tool we need is EnergyPlus's IDF editor. Now, you can get IDF editor by typing it here, but of course you should have already EnergyPlus installed on your computer. If you are working with the DesignBuilder, then you will need EnergyPlus version 8.9. So let's see where we can find it. It's called EnergyPlus.net. Press enter. And this version is 9.4, but if you go to download EnergyPlus, you see its previous versions. And 8.9 is the one you need to work with DesignBuilder. If you are using Rhino Grasshopper and the Ladybug tools, then there's a different number, I think, that it supports. So you need to download it and install it, and after that you can simply type IDF editor, press enter. It should bring up the IDF editor. Okay, now this is an empty document. Let me load the file we exported. That's our base shoebox. You see the difference. It's actually this is 001 that DesignBuilder writes to the IDF file. That's causing that mismatch. Not a big issue here. So here you see each row on the left marks a type, and those numbers there are how many objects of that type exist in the current model. That means this means no object of this type exists in this model. Okay, so we have a version that we have seen. We have a simulation period, a run period object. That's another object we have seen in the text. They are still visible. So what's good about the IDF editor? First, it lists all the object types you can use in EnergyPlus. As you can see, there are lots and lots of them. And when you need to add a new object, for example, this one, create a new object. Now this will insert a new record, new object into your model. And for the field that have only limited number of choices, I will list the choices for you, and so you don't have to memorize everything, like there. And there are some hints about the current object, and you see the definition of each field clearly in here. So those are very helpful when you are editing, especially adding new contents to your model. However, the list is very long, and it's not really easy to go through it and find what you are looking for, even though they do have a search function for that. But for beginners, if your purpose is to learn about the structure of EnergyPlus models and to find out what objects you can use in order to create a new model, and also if you want to know more about a particular object type, this tool is not quite ideal. A better place for learning about EnergyPlus's objects is actually here. If you type app.ansims.com, press enter, and this is the so-called IDD browser. IDD is the data dictionary of EnergyPlus, so that defines all the EnergyPlus objects and its contents. So let's just get rid of those. So we are looking at 8.9, and you can see, similar to the IDF editor, you get a long list of different objects, and in each categories you can expand it and see more details. So each of them are different objects. If you check this box, it's called pre-grouped. I put all the objects in different categories to help to mark the place of each object in the role each objects play in the model. Okay, there are 4 categories. The first one is simulation. So those objects controls how simulation is run. For example, the simulation parameters include, well, the version number of the EnergyPlus system, and simulation control, say whether or not do sizing, and run period is not here, but those are the things controlling how simulation should be executed. The building objects, different algorithms, all the details are here. And if you want, so on each tablet here, it tells you the name of each field and what it does. Also, the available options available to that you can use for this field. And if you want more details, you can click on the link for EnergyPlus reference. So if you click here, it'll bring you right to the menu of this particular object type. Okay, so you find all the details and examples, etc. So let's get back here. So the first category defines how the simulation should be run, including how output should be generated by your model. The second part is called BC, which stands for boundary conditions. They include the location and climate data specified in your model. Run period is here, so that's for which period of time you want the simulation to be run. And the site location, the ground temperature, etc. This is the boundary condition of your simulation model. And internal gains, like the definition for people, lights, equipment, etc., they are actually boundary conditions as well. So boundary conditions means that's something set for your model by someone else, but not in your own control. Like the climate, you can pick a weather file, but that's not a design variable you can choose. Exterior equipments, those are the equipments used outside the building. They still use energy, but the energy doesn't contribute to the heating and cooling of the building. So they are lumped together. There are a few of them, and they're lumped together as exterior equipment. Model itself is the objects defining your building model. The first one is the building itself, of course. And for thermozones and surfaces, there you'll see all sorts of objects for you to define your thermozone. You can group them, and there are many different ways to define the building surfaces. Like you can use a detailed wall, you can use a simple wall that is exterior or adiabatic, etc. The model generated by DesignBuilder always use detailed surfaces, so it'll be a detailed wall. It has many input fields. You can go through them. So you define different vertices, its x, y, z coordinates of each, etc. And as usual, you can click on the link to see the details in the menu. Okay, so those are the thermal zones and surfaces. Window surfaces, the transparent surfaces are here as well. So it's the window, glazed door, etc. So the next part is surface construction elements. These include materials and constructions. Now, constructions is composed of different layers of materials. So for each material, you get a name, you get a properties of it, and somewhere you get a thickness. So if you want to vary the thickness of insulation layer, for example, you would find the construction element first, and then find the materials, the insulation material used in that particular construction, and then find the thickness parameter and change that value. Okay. So those are the surface construction elements. The airflow model, different objects define how air exchanged between zones, and HVAC design objects are certain things related to the design calculations, daylighting objects, water system, etc., etc. The next big category is called HVAC, where you find all the equipment and the systems used for defining HVAC. So these again are still categories. Like for fans, there is many different types of fans, and for coils there are even more, many of them. Yeah, so those are the individual objects you can use to define a coil in your system. That's for HVAC. Airflow network, two big categories: room air model and the network model. So they are really quite complex. So I don't think anyone nowadays attempting to create detailed HVAC or airflow network models by hand. So luckily we do have a DesignBuilder and OpenStudio, Rhino, Grasshopper, and Ladybug tools to do such to create a model for you. But it's still useful to browse through it and see what's there, and to understand what's in there in your model, and understand how each object can be used and what the meaning of each field is. Okay, so one thing you can do is actually put a model that EnergyPlus has generated side by side with this side. You can browse through your model, and if you notice something that you didn't understand, for example, what is a material no mass, copy that and paste there, and it'll find the definition of that object for you. And this is the object, those are the fields and all the details, and you can go to the reference, seeing what material no mass is about and how it's used, with the example as well. So the way we work in the future is to use DesignBuilder to generate the baseline model and then make changes to it in order to reflect our design choices. Okay, the last thing I want to show you in this video is how to run simulations using EnergyPlus directly, using the model we have here. The program you need to use is called EnergyPlus. This one. Okay, so once you start it, it shows you a fairly simple dialog where you can choose the model you want to run, and that's the baseline shoebox model we have. So, and also you need to choose a weather file. So let me browse my weather file. That's our weather file. So I'm going to use the weather data from St. James Park. Let's open that. So that's the model, that's the weather file, and now we can click on Simulate to run simulations. Very quick. It's small models, takes no time. It will report if we found any problems with the model or not. Okay, here it shows the EnergyPlus run status. You can see the run has completed, and EnergyPlus completed successfully with 10 warnings. Now, if you see some warnings, normally they're not a big problem, but you should check nevertheless. But if you do see some severe errors, then you shall definitely pay attention. Now we can close that. We can check what are the warnings using the output files. This section shows the available output files generated by EnergyPlus. And errors is the error report. So if you click on that, it brings up the contents of the error report file. And you see the items of warnings here and here, etc. And you should check through it and see if there's anything may affect the accuracy of your simulation. Okay. The other output tables is the summary tables generated by EnergyPlus. This actually shows it in CSV format. It's not easy to read this way, but there's a HTML form of that tables as well. So if you go to Assets and click on HTML, it should bring up the tabular report, the summary report from this simulation, and you will get the total energy numbers, the things used in the simulation, summary of building area, etc. and all sorts of details about your model and the simulation outcomes. Okay. So the next one, DXF file is the 3D model. I can't easily open DX files on this computer, but I can view VRML, but this is not generated at the moment. To get it, we need to edit the model. Let's use IDF editor. So, okay, don't worry about that. And we shall find the output section and find 3D models. Output surface drawing. As you can see, this one is requesting DXF output. We can actually duplicate the object and change this to VRML, and then save the model and run simulation again. Okay, this time we got a VRML output. If I click on that, still doesn't work. It's okay, we just need to go to the output folder and open the file manually. So this is where my baseline model is, and those are actually the simulation output files. Now that's the 3D model, and I can double click it. Now this is Windows 10, and it has this 3D modeler that is very convenient to open VRML files. It's not great looking, but at least you can see what's in there. It's just a box with a window and a shading above that window. Okay, so this is the way you can check the geometry. Right, what's next? The ISO file and the meter files are the main data output. If you click on the ISO file, on my computer it has already been associated with DesignBuilder Resource Viewer, so it opens that ISO file if I click on that button, and we can have a look at the temperature. That's the mean air temperature. Suppose the operative temperature or mean radiant temperature is here as well. So okay, that's about it. That's how you use EnergyPlus directly. So you get a model in text form, and you can make changes whichever way you want. And then once you've done your changes, you can run simulation using EP Launch and look at the results.